Mercado math, it's time to do some math. Let's Merca do it. Alright, so today we're going to talk about adding and subtracting radicals. Now, good news, this is all going to seem very familiar to you. It's going to be kind of the same thing you did in Chapter 1, which is just combining like terms. If you can combine like terms, you can add and subtract radicals. So, I'm just going to review adding and subtracting like terms because honestly, the mistakes you made then are going to be the same mistakes you make now. So, let's just show you real fast. When you add and subtract like terms, you find them matching. There's an x, and there's an x. 3x minus 4x is a negative 1x. Now keep in mind, you really don't need the 1 there, so you would just kind of leave that as a negative x. I have a 5x squared and a minus x squared. 5x squared minus x squared. Remember, there is kind of this implied 1 in front of that x squared. That becomes a 4x squared. You have learned in Chapter 7, if you remember, there is something called standard form. Good news, that doesn't really matter with radicals. But technically, you would write this as 4x squared and minus x. That's not a thing anymore. We don't really care about that. But we're going to keep going. So this is all very similar. If you look, I kind of have the same numbers. The 3, the 5, the 4, and the negative. Pretty much the same idea is going to happen. When you add and subtract radicals, you can only add and subtract like terms. You need the matching radical, and it has to be identical. Just like these x's had to be identical. You cannot add x and x squared. I cannot add radical 2 and radical 10, but I can add this 3 radical 2 and this minus 4 radical 2. 3 minus 4 radical 2 is a negative 1 radical 2. These radical 2's don't cancel out, just like that x didn't cancel out. That 1's not really going to be there. I can combine this negative 5 radical 10 and this negative radical 10. There is an implied 1 here, so I made that a negative 5. Same crap. Negative 5 minus 1 would be a negative 6 radical 10. Very similar setup, okay? Now what we're going to do is we're just going to try to do a few other ones, all right? So let's clear the board and do a few different ones. Here's another example that you might look at and go, holy crap, this looks crazy. This is the sort of math that looks more impressive than it actually is. It's the sort of math that if you show people a lot younger than you, they seem very impressed, but you didn't really do much. You just kind of added and subtracted. We look for like terms. Once again, they're not really like terms, but you get the idea. Like radicals. Radical 5, and I see a radical 5 here. The same mistakes you made when you did this in Chapter 1 are the same ones you're going to make now. Just, if it helps, put the 1 there. You don't need to put it there, but if it helps, do it. 1 radical 5 plus 1 radical 5 is a 2 radical 5. So this right here is a 2 radical 5. In a perfect world, you're keeping track of that in your head. I'm going to write it down just so you see it. 2 radical 5 minus 6 radical 5 will be a negative 4 radical 5. We keep going. Oh, it's got this minus 4 radical 2. I got nothing else for it. There's no other like terms. And that's not a problem. You just bring it along. Minus 4 radical 2. This is your answer. It's a little multicolored. That's a beautiful thing. But that's it. Alright? This one down here. This has 6 terms to it. There's a whole bunch of crap going on down here. But when you look at it, you just look for those like terms. It looks very complicated. It's not. Like terms. 4. 4 is just a regular number. It's an integer. I look for another integer. 9. 4 plus 9, 13. That one's done. 3 radical 11 plus radical 11. Remember, there is this implied 1 here. 3 radical 11 plus 1 radical 11 is a 4 radical 11. Over here, I have this minus 5 radical 6 and this minus 12 radical 6. Combine like terms, and you will get a minus 17 radical 6. Okay? You do not add the radicals. Common mistakes, people are going to get things like 4 radical 22 and things like that. Just like people used to screw up x plus x. X plus x is 2x. A lot of you have screwed up before. X plus x, you put x squared. That's a common mistake. You're going to make mistakes when you do this too. With more practice, just like terms, you'll get a little better at it. All right? Now we're going to do some better ones, some slightly harder ones. Not harder, just using the crap you did earlier in the chapter. So at first glance at this one, I don't have any like terms. I see a radical 8, radical 10, radical 2, radical 40. It seems like I can't do anything. However, you got to remember that main part of the chapter is breaking down these radicals, simplifying them. So what happens is, ideally, you have done enough practice problems where you kind of start spotting some of these, like that radical 8. You probably broke down radical 8 a few times already within the homeworks and seen it on practice problems, unless you're not doing any of that. But radical 8, I can break that down. That is the square root of 4 times the square root of 2. The square root of 4 is 2. I have a radical 2 still hanging out there. There's a 4. I'm going to bring that down. And 4 times 2 is 8. So this is 8 radical 2. And you kind of see what's happening here. I now have a setup there. 6 radical 10, can't do anything with, so that's still just 6 radical 10. I'm going to bring that down. Oh, yeah, let's go. We keep going. All right, now I have this 9 radical 2. I can't break down radical 2, so it's just minus 9 radical 2. Now 40. I can break down 40. 40 can be broken down with the square root of 4. It's 4 times 10. The square root of 4 is 2. I have a radical 10. So this is plus 2 radical 10. And now when you look, you should see those like terms. 8 radical 2 minus 9 radical 2. That's a minus 1 radical 2. I'm just going to write it as a negative radical 2. If you want to put the 1 there, it's not wrong. You can absolutely do it. 6 radical 10 plus 2 radical 10. That'll be a plus 8 radical 10. I'm going to give you one now. I recommend trying it on your own. I write it on there. You pause the video, do it on your own. See if you get the same answer as me. You could also just watch it if you want, but this is where you really should kind of be practicing on your own. Okay, so this is where, in a perfect world, you're pausing the video and you're trying this on your own. Hopefully you get the same answer as me, or hopefully you actually at least try this. So the goal is really to kind of look at these numbers and figure out which one can you simplify. You go through your square roots, 4, 9, 16, 25, 36. You kind of don't have to go too crazy with them, but 4 and 9 are always very popular ones. 27 is 9 times 3. That's a perfect square. I can break that down and simplify it to a 3 radical 3, because the square root of 9 is 3, and that's just hanging out. Bring down this 10, it's still there, and you get a 30 radical 3. 10 radical 27 simplified to a 30 radical 3. We keep going down the line. 20, can I break down 20? Yeah. It's the square root of 4 times 5. Square root of 4 is 2. I know the square root of 4, that's why you use those numbers. And you're left with a radical 5. I'm going to bring down this 4 or bring down the negative 4, whatever you want to do. Whatever makes you feel like you're not going to screw up. That gives you a negative 8 radical 5. That one's done. 75. Not 4, not 9, not 16. Oh, 25. It's 25 times 3. The square root of 25 is 5. So there's no number in front of here, so I can just write plus 5 radical 3. Then I have this minus 6 radical 5. I can't do anything with 5. It's just 5. Nothing goes into it. You don't have a lot of choices there. It's a small number. And just to keep all the colors different, let's go with a blue. 6 radical 5. Well, I went from having no like terms to having a pair. That's gone. 30 radical 3 plus 5 radical 3 is a 35 radical 3. Once again, common mistakes would be putting like a 6 there or something. People add everything. People add these numbers and the radicals. That's the problem. Don't be that person. Minus 8 radical 5, minus 6 radical 5. Same sign. When you have the same sign, you add, keep the sign. That's a negative 14, and that's going to stay radical 5. Once again, like terms. They're alike, so is the answer. Like terms, everything stays alike. Okay? The next question is going to be a bit of a bonus. We're going to have a little geometry question for you. So, we're going to find the perimeter of this rectangle. Once again, you've done perimeter and area problems a ton in this class. We are just going to find the perimeter, which is the distance around the shape. So, you're really just adding up all of the sides. Common mistakes that happen, people just add up these two sides. You're adding up all the sides. There's 4 of them. It's a rectangle, so you know very well what these sides are. Now, when I was your age, I literally just added up all 4 sides. I would write this out. I would put it here, and I would add it up from there. There is a formula. I might do the formula real quick at the end. I think the formula, I mean, there's nothing special about it. We'll write it. I think it's harder to remember it than actually do anything. It's easier just to do this. But here we go. We're going to add up all of the sides. 4 plus 6 radical 7 plus radical 7. That side. I'm going to add this side. Plus 4 plus 6 radical 7 plus radical 7. And if you look, I have 4 different sides right now. Okay? Here's my one side. Here's another. Here's the other side. Those are my 4 different sides. And once again, you can ideally do this from here. You don't have to rewrite it. A lot of you can probably do 4 plus 4 is 8 without having to rewrite this horizontally. But for a lot of people, this is kind of what you expect, and people just like familiar things. Let's see what we got. Let's go purple. Well, I said it before. 4 is an integer, regular old 4. We're not doing 4 plus 6. This 6 is attached to that radical 7. Do not add these two. That's another old mistake a lot of people used to make. The only other regular number is that other plus 4. So that's going to be an 8. I have radical 7. I have a bunch of radical 7s. Look at all of these. There are I forgot to actually write radical 7 on this guy. There are 4 different radical 7s. Remember, in front of this radical 7, there's that implied 1. If it helps, write it, okay? You don't have to, but if it helps, it helps. 6 radical 7 plus 1 radical 7 is 7 radical 7. 6 radical 7 is where am I at? 13 radical 7 plus 1 radical 7 is a 14 radical 7. That technically this is perimeter, so it would be units. Okay? Not units squared, that's area. This is just units. Some people care about the units more than others. In math, like I said, in math, to be honest, we care more about the numbers than the units. But in science, the units are a very big deal. So it's one of those understanding the math and then applying it. When you apply it, you really want to write the units. If they put centimeters and you forget it, people take that personally. In math, to be honest, I'm pretty happy with just having the number here. The formula, if you wanted to use the formula for perimeter, and the thing is, like I said, there's a bunch of different ones. It's 2 times length plus width, or 2 times the length plus 2 times the width. So, I mean, you have some options there. If you wanted to use them, you could do that. If I'm being realistic, when I do this in my head, I kind of use this one. But there's nothing wrong with writing it out. You can use the formulas. It's 100% allowed. In fact, this is probably the way they want you to do it. I'm not that guy. All right? And now let's see what I'm going to draw. It's a well because, well, you made it through the video, and well done, guys.